Well, here in Lecture 3E, we're going to look at solubility predictions. Specifically, we're going to look at can a solid form and will a solid form. So we want to be able to predict whether we're going to get a precipitate in a solution. Now, solubility rules help us determine if it's possible for two ions to be able to form precipitate. All those tell us is, will they come together and have the ability to form a precipitate? But those rules do not take into account concentrations or any of the other equilibria that might be taking place inside the solution. So the rules cannot predict if a precipitate will absolutely form for a given set of conditions, just that two ions can come together and form precipitate. That's all that those rules are able to do. Now, to determine if a precipitate will form when two solutions are mixed, first we have to determine if there's even a possibility for a precipitate using those tables. Do we have two ions that form an insoluble salt? Okay, next we have to look at the concentrations of those ions that we want to have form a solid. And we have to do a QSP calculation. Again, the only difference between a Q calculation and a K calculation is for a Q, we don't know if it's at equilibrium. For a K, we know it's at equilibrium. Other than that, the two equations are exactly the same. So we're going to use a Q calculation. We're going to compare it to a KSP to see if we have enough ion present in order to form a precipitate. If the QSP is greater than the KSP value, then a precipitate will form. If the two values are equal, then technically you are not going to get a precipitate, but the solution is saturated, and any addition of either the cation or the anion will result in a precipitation. If the QSP is less than a KSP, even though you have ions that can form precipitate, they will not actually form a precipitate in the solution because the solution is not saturated, so they're not to a great enough concentration within the solution. So let's look at an example. We are going to add 200 milliliters of 0.0040 barium chloride to 600 milliliters of 0.008 molar sodium sulfate. Will a precipitate form? First thing we have to do is take a look at the ions that we have in solution after the two solutions are mixed and see, do we have two ions that can come together according to the solubility rules and form a precipitate? You see, barium chloride will separate into barium ions and two chloride ions. So most chlorides are soluble. Barium is not one of the exceptions, and so they do come apart just fine. Sodium sulfate. Sodium is a group 1 metal. All salts of group 1 metals are soluble, so I know that sodium and sulfate are going to break apart and cannot form a precipitate. However, what we do see is that it is possible for barium and sulfate to come together. Most sulfates are soluble, however, barium is an exception to that rule, and so we do get a barium sulfate solid. So we have two ions that can form a precipitate. When we look at barium sulfate, we see that it has a KSP. That's always a good indication that it's an insoluble salt, and it has a value of 1.1 times 10 to the minus 10. Now, we're adding two solutions together, so we cannot just take our concentrations here and here. We can't just use the 0.004 and the 0.008 because we are mixing two solutions together. So we have to calculate new concentrations by looking at the dilution factors. So for the barium, I'm just going to use my M1V1 equals M2V2 equation that we learned back in Intro to Chem. So we have 200 milliliters of 0.004 molar barium sulfate. That's going to go into 800 milliliters of solution because we have the 200 of barium sulfate and 600 of sodium sulfate, barium chloride rather, and sodium sulfate. And that's going to give us 800 milliliters. And I'm going to calculate the new molarity for the barium in that solution. It should come out less because it's being diluted, and it does. It comes out to be 0.0010 molar. So that's the new concentration of my barium. For my sulfate, the same thing, but I'm going in with 600 milliliters originally times its 0.008 molar concentration. My new volume is still the same, 800 milliliters, because it's going into the same solution as the barium. And my M2 is what I'm looking for, and that gets calculated at 0.0060 molar. We're going to do a Q calculation. It's going to be the same as my KSP, concentration of barium, times the concentration of sulfate. That's going to give us 0.001 for the barium times 0.006 for the sulfate, and I get 6.0 times 10 to the minus 6. Not a very big number. However, it is still larger than my KSP, which is 1.1 times 10 to the minus 10. Since the QSP value is greater than the KSP value, that means that my concentrations are higher than they are allowed to be in solution, and so the solution is oversaturated, and so some of those ions have to be removed, and they're going to be removed by the chemistry by precipitation. And so a precipitate will occur, and it will continue to precipitate until the product of the two ions match my KSP. Let's look at another example. Here we want to know if we're going to get a precipitate. So now we have a solution that we know the concentrations of the two ions that are in there. We're not changing the volume at all. So I want to know if I will get a precipitate of strontium sulfate. I know that the concentration of my strontium is 2.5 times 10 to the minus 4. Concentration of my sulfate is also 2.5 times 10 to the minus 4. And my KSP is 3.4 times 10 to the minus 7. So for this problem, we're going to calculate a QSP, compare it to the KSP, and see if we're going to get a precipitate. So our equation is just strontium sulfate breaks apart into strontium ions and sulfate ions. This gives us a QSP expression of concentration of the strontium times the concentration of the sulfate. Again, it's just a 1-to-1 because they're both 2 plus and 2 minus ions. So I have 2.5 times 10 to the minus 4 for my strontium, 2.5 times 10 to the minus 4 for my sulfate. When I multiply this together, I get a 6.25 times 10 to the minus 8. And what I see is that my QSP is less than my KSP. So even though strontium and sulfate want to form a precipitate, my solution is not yet saturated, and so I will not get a precipitate in this case.